Alright, so what we have here is determine the percentage composition for each of the compounds below. And I've already sent you the image of example problem number 1, which was potassium permanganate. So now let's take a look at problem C. So this is magnesium nitrate. So we see that there's one magnesium atom, there's two nitrogen because of the two subscripts, and there's six oxygen because the three subscript times two subscript. So let's just start by writing down the compound here, atom by atom. So we have our magnesium, we have our nitrogen, and then we're gonna say how many nitrogen we have. So two, or we could do it like this: two nitrogen and six oxygen. So now we're going to reference the periodic table, and we can see that the atomic mass of magnesium is 24.3. And then the atomic mass of one nitrogen is 14.0. And then the atomic mass, and times 2, because we have two nitrogen atoms, so we're going to get 28.0. And then we have six oxygen atoms. So we're going to look back at the periodic table. It's 15.999. We're just going to round up to 16.0 for the sake of making calculations a little bit easier. And there's six of them, so 16 times 6, it's going to give us 96.0. So now what we're going to do is we're going to add the sum of these numbers. So 24.3 plus 28.0 plus 96.0, and that should leave us with a total of atomic mass being 148.3 grams per mole. But since we're not going to be doing any kind of calculations with any a quantity like grams or number of molecules, we're just going to focus on the number itself because we're focused on the percent composition in this situation. So now we have, this is our total mass. In order to find the percentage, we're going to take, for example, magnesium. We're going to write its atomic mass, divide it by the total mass, so that's going to be 24.3, divided by 148.3, and then we're going to times that by 100 to get our percentage. And that's going to leave us with that's going to leave us with 16.4%. Now I'm working with three significant figures. So 24.3, that's 3, 14.0, that's 3, 16.0, that's 3. So we could leave this as it is or just have 148. Does it affect the calculation? Very little. So if we want, we could just go to do 28.0 divided by 148 or 148.3. So because this is a total mass added with the significant figures, we can keep it, but should you choose to drop it, it shouldn't affect the percentage calculation all that much. So we're going to do that times 100. So it's going to be 28.0 divided by 148.3 times 100. And that's going to leave us with 18.9%. So it's good to specify to make sure that we have it all lined up. So on this line, it's magnesium. On this line, it's nitrogen. And then on the next line, it's going to be oxygen. That way we don't mix ourselves up and make a little placeholder. Say this is nitrogen, this is magnesium, and then the next one's going to be oxygen. So for oxygen, we're going to do 96.0 divided by the total mass 148.3, and then multiply that by 100 and calculate our percentage that way. And that's going to leave us with 64.7% of oxygen. So now if we add these percentages up, 16.4 plus 18.9 plus 64.7, it's going to be exactly 100%. And that's another way we can kind of make sure we're not doing anything funky with our numbers and we didn't put in the wrong number or we didn't put in an extra zero. So in some cases, in future problems that you do, you might get something like 99.9 or 100.1. That's all right because we're only working with a certain number of significant figures. However, if you started to see anything, and different teachers will tell you different things, but when I was doing chemistry, typically if you saw anything less than 99.5 or anything greater than 100.5, you might want to double check your numbers because if you're half a percent more off the margin, two things could have happened. You could have typed maybe a 9 instead of an 8, or you're working with too little or too many significant figures, and that could throw your percentage, the cumulative percentage of these atoms could be messed up a bit. So just keep an eye on that for future reference. So when you write the answer to it, just circle and specify or box in, hey, these are my percentages of these. That way your teacher can see per atom or per atom of the formula of composition.